This is Kinsey and I's presentation on inverse functions. And inverse functions are the function that replaces another function when the dependent and independent variables of the first function are interchanged for an appropriate set of values of the dependent variable. This slide is on symbolic representation, such as special symbols and function notation. And the special symbols include f of x, g of x, h of x. And if you have f to the negative 1x, then you have to do the opposite of what is said, so that's the inverse function. And a regular equation would read y equals 5x plus 4, but a function notation would read f of x equals 5x plus 4.
This is our example on function notation. Function notation is a system of symbols used in mathematics. First, we want to plug in f of negative 3 into all the x's in the problem. We want to do this because our overall goal is to find out if we plugged in negative 3 for x, what would the final answer be? The same thing if we wanted to plug in negative 2, negative 1, 1, 2, any number. So this would be negative 27 plus 6 plus 1 over negative 2. And that would come out to be negative 21 plus 1 over negative 2, which that means our final answer is 10.
Okay, so now this is graphing inverse functions.
I'm going to show you guys how to graph an inverse function. A function and its inverse will be symmetric around the line y equals x, which means you can switch the position of x and y. So this function is f of x equals 3x plus 6. F of x is also saying y, so y equals 3x plus 6. First, we have to figure out if this function even has an inverse. So how I'm doing that is doing an x and y chart. So I'm going to plug these three numbers into that equation. So to do that, it's 3 times 1 plus 6, which would be 9. 3 times 0 plus 6, which would be 6. And 3 times negative 1 plus 6, which would be 3. So that's how I got it. So 9, 6, and 3. So since none of these y values are the same, then it has a function. So now we can find the inverse. Okay, so to do that, we can switch to x and y. So x equals 3y plus 6. We have to get the y alone, so we have to subtract 6 on both sides. So it would be x minus 6 equals 3y. Now we can divide by 3 on both sides. So it's y equals 1/3 x minus 2. But the inverse function is f of negative 1x, 1/3 x minus 2. So this is the inverse. And this is the function. So now we're going to graph. Okay, so I'm going to graph the function first and then the inverse. So I'm going to go up 6 and go down 3 over 1. And then draw the line. Okay, now this is the original one. Now we're going to do the inverse. We're going to go down 2 it wants us to go up 1 over 3. Up. And then down 1 over 3. Down 1 over 3. Okay, and you can see that it intersects right there. So now we can find the line of symmetry. So since y equals x, the y-intercept is 0 and the slope is 1. So 0, 1, 1, 1, all the way up, and then all the way down. And then that will show you that these lines are reflected towards each other. So this is how you would graph an inverse function.
This is just another example on how to graph inverse function with an exponent in the equation.
I'm doing another example on how to graph inverse functions. But this time we're going to graph inverse functions with an exponent in the problem. So what we want to do first, we want to find the inverse function. So we'd start out with the original problem, and then we'd switch to x and y. So it'd be x equals negative y squared minus 1. Add 1 to both sides. X plus 1 equals negative y squared. Multiply by negative 1 to get rid of the negative sign on the y squared. Y squared equals negative x minus 1. Take the square root of both sides. And it'd be y equals plus or minus the square root of negative x minus 1. So this is our inverse, and this is our original. If we wanted to graph the original,
My bad. Next. Go ahead.
Oh, okay. So this is the property of inverses. If f and f negative 1 are inverses, then f of a equals b. And if and only if f negative 1 b equals x. For example, let f of x equals x minus 12. And the inverse is f of negative 1x equals x plus 12. So some examples is f of 20. So you plug in 20 for the x, and it'd be 20 minus 12. And so 20 equals 8. And then for the inverse, it'd be, you can plug in 2 for the equation, and it'd be 2 plus 12, and that would be 14. That's our presentation.
All right. All right, ladies and gentlemen.